Hello, everyone. My name's Ali Rizwan. Today we have the topic of using Airflow and GitHub to build some pretty neat pipelines to execute your SQL pipelines, from GitHub on Snowflake. So we're going to be talking a little bit about Airflow and integration with GitHub and Snowflake. So it's a pretty interesting, pretty neat topic. We've got, Alex here on the call with us as well. So about myself, my name is Ali Rizwan. I'm a data engineer, kind of been building data warehouses and kind of data applications for healthcare clients for the past few years. And we've got Alex Schlutzen. He's an Airflow engineer, kind of very much an expert in Airflow. And let a few minutes to talk about yourself, a few seconds to talk about yourself, Alex.
Hello everyone. I worked with Airflow since the very beginning of my career. Works with lots of different versions, including the first one and all major second one. I've done migration from first to second. And I also contributed to open source Airflow providers. So this is my experience with Airflow.
Cool, very cool. So yeah, very excited to get to learn a little bit from Alex about Airflow today. So this is how the talk is going to go. We're going to do a breakdown, kind of give a quick intro to what is Airflow. Alex is going to walk through some of the key concepts. Obviously, this is not an exhaustive list of how Airflow works. This talk is kind of very focused on a specific use case, and we're going to really talk about key concepts that are focused on that. We're going to talk about kind of common use cases for analytics engineers that we're going to talk about. We're going to define what the role we mean by analytics engineer, and a lot of the talks in our challenge have been really focused on that. And it's really kind of tailoring Airflow to their needs, and using Airflow, for their use cases, kind of mainly kind of creating transforming data and creating data sets, and how to make sure your the data sets that are going to be consumed are accurate. Then we'll walk into kind of more or less what our demo is going to be about, and how the project's going to flow. So basically talk about, use cases for analytics engineers and how this demo addresses that, and a little bit of detail about the demo itself and how it's going to flow, so that when Alex is going to walk through, you guys can follow it. So with that, what is Airflow? So, Airflow it's basically a data migration tool that was started at Airbnb. It's basically an open source platform. It's more like an ETL tool, right? Like, so the way I think about it, it's an ETL tool, a data engineering tool to kind of do many things. To migrate data from one place to another, and then using basically open source, Python libraries, right? So Airflow, it has a little bit of a GUI, but really the core functionality is not like drag and drop. You're really writing Python code, Python operators, as what they're called, little chunks of Python functionality that you can incorporate into your pipeline and do certain things, whether, like, we're going to talk about connecting to GitHub and pulling a file from there and modifying its content, or kind of making a connection to Snowflake or writing to it. It's really, I would say, like a data engineering ETL tool with a real foundation in Python, right? So it's the way we're going to show it, I'm going to have it installed on my laptop, and the demo is going to be kind of contained here, other than kind of connecting to our GitHub repo and whatnot, and Snowflake. But the installation of Airflow is kind of limited to my laptop. But it's available in many ways. You can get it from different cloud providers as well. I've got a link here in the documentation to kind of review further. But basically, simple terms, data engineering tool where you're using Python operators to do certain tasks, right? So Python is kind of a prerequisite, a big prerequisite for using Airflow, and my experience and my introduction to it that I've been working with it. So with that, we'll go into some key concepts that we're going to talk about, we're going to use and reference here. And Alex is going to kind of touch base on these because, he and kind of walk through these.
Yeah, thank you. So there is a lot of different concepts in Airflow. We will cover there mostly 4 of them. First is a DAG, is a direct acyclic graph. It's pretty widespread in the engineering world, and what it does in Airflow, it collects tasks together and say them how to run, like in what schedule, how many tasks simultaneously, how many pipelines simultaneously, and so on. And what relationship between this operator, what operator goes what after another. And then we go to operator. Operator basically is a template for the task. There are all sorts of operators like bash operator, which execute bash command, Python operator, which executes Python code. And in this demo, we will cover HTTP operator and Snowflake operator and sort of like Python operator. By itself, operator is an isolated workload, and it can't communicate one to another. So there is we go to XCOM. XCOM is a short from cross communication. The way how it works is there is an XCOM backend, and each operator, each task, write its result of its work to this XCOM backend, and all other operators can read this data. And obviously, after reading, they writing the result of its work there. And we will cover connections. Connection is the way for Airflow to connect to external services. As Ali said, there is a lot of different pipelines in data engineering world, and you have to connect your pipelines to the, say, MySQL, Snowflake, and so on. And to do it in a secure way, there is a connection because it's all in one place, and password is secured, and like it can be shown to the one who don't know it. So basically, this is it.
Great. So basically, we'll kind of walk through these in detail and how this kind of diagram here is basically the details will be covered. These concepts, kind of we'll put them together in the demo and next few slides. So here we're talking about common use cases for analytics engineers. So when we say analytics engineer, and kind of what do we mean by that, and what are we going to be focusing on in this in this talk in particular, right? So what we mean by analytics engineer is somebody who is responsible for modeling data into kind of clean and accurate data sets. So if you are a modern data kind of data shop, you've got a team of data engineers, which it's a commonly used title for folks that are in the way I'm describing it, that are basically taking data from different raw data sources and they're bringing it into a data lake, right? So that I'm representing here by the raw data, kind of picture in the diagram, right? So analytics engineer basically take that raw data, and they're in our case, we're using Airflow to kind of schedule and kind of pick up SQL from your GitHub files that are in your Snowflake, and then applying those SQL statements to the raw data, creating data sets and then writing it to tables, that come into the transform data layer, right? Which are then used by kind of subsequent teams, your Power BI developers or your Click developers or other tools, other BI layer tools, right? So what are the challenges? Obviously you want to make sure your transform data is up to date, and also you want to make sure your scripts are up to date, right? And that's kind of why we're going to show a little bit how the GitHub integration works and why that's important, right? Because we want our analytics engineering pipelines to be a little bit separated from the data engineering pipelines that may be bringing data into the data lake and the raw data. Because once the data is there, the SQL statements and the scripts are kind of disassociated from those pipelines into their own repo, right? And that's a use case that we're going to show, where your GitHub has its own repository for your SQL statements and for and how Airflow could kind of pull those in and execute that against your Snowflake instance. So a little bit about the kind of details of what we're going to be using here and what we're not going to be using, right? So first thing is, Airflow does have the ability to kind of take data from different kind of raw data sources and bringing it into Snowflake, right? So we do have, so in the diagram you can see we've got our Snowflake database here and this raw kind of table here, right? So we may have data coming from different source files, and you do have operators, within Snowflake. For example, if you're an AWS shop, you have an S3 bucket that has a bunch of source files. You can use Airflow's S3 to Snowflake operator, which we're not covering here, maybe in another session, but you can pull that data, use the S3 to Snowflake operator and kind of bring that data, stage that data and bring it into Snowflake into, your data lake environment. That piece, we're not really going to go into deep here, right? We're going to assume you've got your GitHub file, over here, and we're going to have a SQL file, which, with a simple kind of create table as statement, right? Like you have a create table, your table name as, and then a select statement, right? And those select statements are really where in the ELT world, that's the T and the L, of the ELT world, where the transformations are happening that are taking the raw data and kind of manipulating it for use by data teams, right? Which are really and still by and large, in the data lake environments like Snowflake, the most of the BI happens with SQL, right? So those SQL files are going to be in your GitHub repository. You can use, use SQL against Snowflake, but we're going to show how to connect it, pull that file from GitHub using the SimpleHTTPOperator. You can, use we'll talk a little bit about XCOM and kind of how that works, where you can take, the results from one operator, which is a SimpleHTTPOperator, which is going to pull the SQL file. Then we're going to do some modification to it. For example, there's a table name. We want to define the table name and kind of parse the table name in a certain way. That table name is going to be defined and parsed within our Airflow, DAG, and then pass that the output of that to another operator, which is the Snowflake operator. So the GitHub file gets pulled in by the SimpleHTTPOperator, gets parsed and modified, and then gets passed to the Snowflake operator, which is another operator that then connects to Snowflake and then executes that SQL against your raw, data that's brought in, and then create it as a table in the final Snowflake table, right? So that's going to be the workflow that we're going to go through. And it's really as we mentioned, right? Like the benefit that we're showing here is that we really want our because you can have your Airflow pipelines and Airflow projects and also be part of your GitHub repository, right? But typically an analytics engineer that is just writing SQL all day, right? They may not know much about Airflow. All they need to know that, hey, I need to create my SQL statements, which are, part of my because I know the data model, I know the data, right? So all I have to worry about is writing my SQL. I can write it out in Snowflake. Once I'm done testing it, unit testing it, I can then take that SQL file, put it in my GitHub repo, do peer reviews on it, and then push it out, for its consumption by the SimpleHTTPOperator, and then I don't need to mess with Airflow, right? The Airflow pipeline can be separate from the actual data transformation that I'm doing within the SQL file that's going to live in GitHub. So, we'll walk through the HTTP operator and kind of how you can configure it, like how it can go to a specific branch or, to connect to your GitHub and how all that works to kind of let you achieve that, separation, as it were. So with that, we'll go into the demo here. Let me kind of go into our DAG, and I'll kind of let Alex take it over from here.
Yeah. So we are starting. So let's go with our demo. We are starting on here is the main Airflow screen. There is a list of DAGs. In our case, we have only one, our SQL upload DAG. Let's look on it. Let's go to the graph view. There is shown 3 tasks. As Ali said, our pipeline done in 3 steps. Like we are getting this SQL query from GitHub via SimpleHTTPOperator. Then we are parsing it via Python operator, but it's done in a different Airflow API. And we're executing this in a Snowflake. So let's see our GitHub file. Here it is, our SQL file. As you may see, the table name is not specified yet. And it's a simple create or replace table as select statement. Let's go to the Snowflake and first of all, let's see into this table. Sorry.
So this is our source query in that's in our GitHub file, right?
So it's just a simple table with two columns, and we will add one more columns here that Ali did the first one. So just we will create a table which is named Airflow Dev. It's a little spoiler, and let's check that it is right now. It's not here.
Right.
Oh, sorry. Yeah, there is no such table. So first of all, I guess let's look into that code. As Ali said,
so actually, Alex, can you go back to the Snowflake screen if you don't mind?
Yeah, sure.
Yeah, so the first query that's in the first line is actually the query that we're going to run, right?
Mm-hmm.
That's in our GitHub file. And the second query, the table, dbt test airflow dev, is our target table that we're going to write the results of that select star, comma, Ali did first test run results into this target table. So, so basically the first on the query on the first line is the same query that's in our, GitHub file, and the target, which, the target table doesn't exist. As you can see, the dbt test airflow dev. The dbt test airflow dev is our target table that by the time we're done with this, that's going to be the table that's created, which we're going to kick off through Airflow to create that, right? So that's going to be the workflow that we'll go through. But at the moment, the table's not there, right?
Yeah, yeah. And let's go to the DAG. This is, as you may see, is a Python code. There is a whole bunch of imports and some values, but let's back to it a bit later. We start with our DAG creation. Here it is. Here is we set in SQL upload. It's a DAG ID. You may see it in the first screen. We set in there schedule interval. In our case, we're running it daily. There are a few additional properties which we will not cover there. It's a start date and catch up. It's important, but yeah, let's go with this in the next run. And default args is default arguments which applied for each operator in this DAG. In our case, we set in owner, amount of retries that task should do before fail, execution timeout. So in our case, if task lasts more than 15 minutes, it will fail automatically. And retry delay, it's a delay between making retries. So in our case, before starting new try, it will wait for 5 minutes.
Right. So this is basically the DAG that we discussed, right? And it's the DAG really, it's one file, even though DAG just is one file that has all the operators, all the actions contained in it, right?
Yeah, and the first task here is a simple HTTP operator. Is the task that getting data, get our script from GitHub. There is a task ID in here, endpoint to this SQL file, method, HTTP method, HTTP connection ID. I will show in a second, and log response. It says whether to log this response in Airflow log. I will show it later. And let's go to the connection. Here's our GitHub connection. It's a simple HTTP connection type. In our case, we specified only host here because it's a public host and you don't need any login and password. It's just automatically run. But in case your source code repository is secured, you may specify a login and password, and it will also be accessible for Airflow. Yeah, let's go next.
One thing I wanted to ask Alex is that, because in our case, our code was in the main branch, right? So if you want to change the branch, how would you do that in your connection? Like if my file was in a dev branch or in a test branch, how would I do that?
You may do this not in the connection, because in the connection you specify a host, login and password. Better it do this in endpoint. Like here, as you may see, it's a main. It corresponds to the branch. So if you want to change the branch for this file, you can specify a different endpoint.
Got it. So the connection is just to basically to the GitHub host, but then where you want to go and where your file is located, that URL, that's defined in the endpoint here.
Correct.
Got it.
Yeah, we get unparsed query from GitHub. Like I'll show it to you one more time with this table name in it. And in our next task, we want to add this table name here. It's a simple Python code. which format this table name and add this table name that we specified in this function. As I said, it's a simple Python function with the task decorator. It's an Airflow task decorator which transforms this function to a Python operator. So next we go to the Snowflake operator. We convert our query, add this table name so we can execute it in Snowflake. Here we specify the task ID, SQL that should be executed. In our case, we pull in that from XCOM backend. As I said, all this task returns the result of its execution to the XCOM. So SimpleHTTPOperator returned unparsed query, and parsed table writes parsed query to the XCOM. And there we are pulling that parsed query by task ID with the help of method XCOM pull. And we specifying the connection to the Snowflake, so this operator will know what Snowflake it should execute this query. So let's go to see our connection. Oh. Here's our Snowflake connection. Here's the connection type. I have to mention that this is not with Airflow by default. We installed an external Snowflake provided to add this. We specify the schema, login. You can be sure that there is a password in here, but as I said, Airflow hides this password, so it's not shown here. Some extra parameters, account, warehouse, database, and so on. And the last part, we specify an order in which task should be run. So first, we get an SQL query, then parsing this table and specifying the table name. In our case, for the sake of simplicity, we hard-coded this value, but yeah, you can go all over with this integration. You can add it in a GitHub, in Airflow variables, and in many different places. And then after we execute this in a Snowflake. So yeah, let's start our day. Maybe, Ali, do you want to add something?
No, that makes sense. So basically, we're pulling the file and we're parsing the table and then we're executing it in Snowflake.
Yeah. So let's start. As you may see, our DAG in the progress. It executes one task, another is successful. It's in the progress. Yeah, it is done. Let's go to the log to see what was happened. As you may see, here's get SQL query executes get HTTP request to this URL and extract our script which logged here. Then we parsed this script. Yeah, one more thing. Here our table name here. And here parsed our table name. It should be Airflow dev, but by default, Airflow is a keyword in Airflow, and Airflow masks all the secured keywords and log. So to make sure no password or like secure information will be exposed in your log. And it executed. Here it's connected to the it connected to the appropriate Snowflake account and executed this query. And as you may see, it successfully finished. So, as I said, all this task return a result of writes result of its work to the XCOM backend. So let's see. Let's see this. It can be seen in admin panel XCOMs. Here our last three written XCOM. Here from get SQL query. Here is the result. Is our table name here. Here result of our parse table, already with Airflow. And here what returns from Snowflake. Status, the table Airflow dev successfully created. So let's check it. Select all from Airflow dev. It is here. So yeah, looks like magic.
Yeah, so it did create it, and we did, orchestrate this, execution, from Airflow. So, if you, essentially want to kind of use Airflow, for these types of kind of use cases, obviously there's a little bit more on the GitHub, what you can do with GitHub, interaction and kind of how in a production environment where your GitHub settings might be. But this is just a simple use case to show, connecting to a public repo essentially, and then taking the results and writing to a table. So thank you, Alex, and thank you everyone for taking a listen. Appreciate it.
Yeah, thank you, Ali, for inviting.
Bye bye.
Yeah, bye bye.